In this system engineering part, we'll see what is that the new part. It is how the states are being defined, how these are being measured, how these are being analyzed. So first need to do the defining all these states, that how these states could be taken place from one place to another, that there are various versions of some document, that the version 1 to version 2, version 2 to version 3. Some states are being changed from state 1 to state 3, state 3 to state 4. So there are various states that actually changes with time. So this state series was been defined by me, and I have defined this in some research paper or something, that how these state series are being evolved and being worked out. So you can find it on various of my various publication. I defined this state series for this evolving systems. So how I defined it? I defined it as the three terms like SI, EI, ERI, and TI. What is that SI? SI is the state. And what is ER? ER is some evolution representer. And what is TI? TI is the time point. So we can define that state SI on some of its evolution representation on some time Ti, so that you can define that evolving system. So what is evolving system? That's also important. The system that evolves with time. So they have the changeabilities, that agents are being applied from, then the agents are being moving from state 1 to state 2. Agents are moving that system from state 1 to state 2, state 2 to state 3. So these agents are being causing the system to move in the different versions because of the improvement or something else. So you have this type of definition could be done, like evolving system could be represented as with these three tuples, and that it could represent this state series. And state series is basically collection of the different states or some data points, we can also say. At such state series could be defined as SS, and this could be said as S1, S2 up to the Sn. So this have the various time points, that actually time point could be at the T1 could be representing this Si, T2 could be representing this S2, T3 could be representing this T3, then Tn could represent this state Sn. And this each state could be represented such that it could be representable with some evolution representer, that state 1 could be represented with the some evolution representer 1. State 2 can be represented with some evolution representer 2. State n could be represented with some evolution representer n. So these type of definition could be helpful for understanding how we are organizing the state series of an evolving system. So I have defined it like this. Somebody could define it in some other way or in some other sense. Then what are the examples that actually been motivating us? So evolving system could be defined in various type of publications, from 1 to X number of papers. And then the solar, some of the examples are like solar power satellites. So what are the solar power satellites? Then the solar power satellites are basically the satellites which actually defines the whole system. Like some solar power satellites are like the satellites that having the various components working together, and these components are being working, and they could have the various type of uh, components, and these component and satellites changes from version 1 to version 2 to version 3. So the satellites also upgrade in itself. So it was being initially was defined by someone, like there are various solar power satellites could evolve with different states, and this could have different impact on the solar power satellites. So similarly, we can see the evolving software system. In software engineering, there are also some definitions like this, that there are various states and various versions of some software that keeps on evolving with time. So you can define it accordingly. Then evolving state series. What are the evolving state series according to that? So in the evolving software systems, you have software version series. So these version series could have version V1, V2, V3 up to Vn. And there are some nature language documents, so they could have document 1, document 2, document 3 up to document n. So these are the nature language documents. So this work was being, I presented that and represented it on the 7th Heidelberg Laureate Forum, and it has been informally published on that abstract of the booklet that has been provided. And HLF Heidelberg Laureate Forum is very prestigious event of mathematics and computer science, where I have seen and met 23 laureates, that there are various laureates that are being invited every year, and 200 selective 200 students all over the world, which would be less than 35 years of age, were selected and being taught by these 23 laureates. So who are the 23 laureates? These are some Turing Award winner, field medalist, and Abel Prize winners. And so this event was being conducted by ACM, IEMU, DNBA, and this work is also been published and represented on that PhD thesis of mine, and abstract of that would be some published on that DuxTool seminar report, and you can find it on various publications. Some of the One of them is like System Network Complexity on IEEE Transaction and Emerging Topics in Computational Intelligence. So you have various places I mentioned this definition to explain the evolving system and its state series. You can find it on many publication of mine. Then evolving systems example. So in the left hand side, this one is actually representing what? The Hadoop distributed file system versions. So there are various versions, that libraries of that Hadoop distributed file system, like 2.7x to 2.6x means 2.6.5, 2.6.4, 2.6.3. Similarly, 2.5.x, 2.4. So these are the various versions of the Hadoop distributed file system, and these are the number of usages, and these are the number of dates that are being published from 2018, 2017, 2016, 2014. Thereafter, some list of English Bible translation are being provided from pre history to the 1066, then 1000 to the 1500 as Middle English. Then modern English is from the 1500 to 1800. This type of a translation list and information was being provided in some Wikipedia page or somewhere else. So modern Christians have from the 1800 to this, modern Jews from 1800 to 53, some miscellaneous. Then you have the various invoices on the retail market from various number of customers. So these are the number of customers from 1 to 51,000 approx. So you have this much number of customers. So these customers are increasing with time, and from 2010, 11, 2010 to 4/1 2012. So this is how you can plot this type of things. Thereafter, you have the multi-sports event. So there are various sports event like Olympic Games, Far East something something, and these type of names are there, and you can have it from the 1890s to the 2020s. So there are various names and various uh, time period of these type of games that has been invented. So these are the name, and these are being invented. So there are various multi-sports event, and like in the Olympics games, similar to Olympics games, there are various Asiad, some X games, then some other African games. So some of the uh, like Australian police leagues. So all these Asian youth games. So all these things are there, like Olympics games. So these are being evolved like this. Then the IMDb movie genre and movies system, that from 1910 to 1940s, you have this type of movie names like The Birth of a Nation, and there are numerous means that these are the number of movies. So these are the not the actually these are just few names out of them, few important names. These are being top movies and the time period of these movies. So you can have this type of evolution and represent this type of series out of them from 1800 to 2000, from 1940s to 1916. So these are basically top movies in these durations, 1960s to 1980s. And you can find out this list in this link. The next, evolving web series system. So you have various versions of software. So software would also have some web series systems, web service systems. So web service systems are also kind of softwares, and they have the various versions, and these versions could also have some special kind of uh, interfaces or some we can say some files or artifacts. That one of them is WSDL. So Amazon Web Service has these numbers of WSDL being published from 2006 to 2014. So in 2006, 2007, 2008, 2009. So these are the number of operations that these type of this WSDL been evolved and been. So the number of operations were keep on increasing for this Amazon Elastic Compute Cloud WSDL. Then Eucalyptus Cluster Controller have these number of WSDL, and these are the number of operations. So you can plot this type of graph and tell the informations like in the Eucalyptus WSDL, Eucalyptus version 1.0, 1.5 up to version 4.3.1. So this is how you can have this type of number of versions. Then we'll see what is system evolution analytics and what are the challenges and what are the problems that are we need to face in the system evolution analytics. So this system evolution analytics basically have the challenging part that are related to some changeability, some evolution, and the various type of definitions are there. So basically you have the two important challenges out of them during mining and learning process. What are the two important challenges during the evolving system mining and learning, evolving system learning? So the first one is some evolving systems are very complex in nature because they were made up of complex systems. So these evolving systems are in complex to be represented. Thus, they required a special kind of pre-processing. So evolving systems are having the very typical kind of pre-processing because these are in the various numbers and they have the various evolutions and they have the various states and they require some challenging kind of pre-processing that actually requires some system domain expert. So only system domain expert, like in case of software system, you need a software engineer to do its pre-processing. Like in case of electronic system, you need its electronic engineer to do its evolving system processing. So pre-processing of that evolving system belonging to evolving system of some software. So the expert of software engineer could only do the pre-processing of that evolving software. And expert of nature language could only do the evolution and pre-processing of that evolving nature language document. So that's the tricky part, pre-processing of multiple states. Then second, you can apply the data mining and machine learning on single state, one state of an evolving system with an straightforward and easy way. But the challenge is that when you have multiple states of the system and you need to apply the data mining and machine learning on the multiple states of an evolving system, then how you can apply that mm, data mining or machine learning on those multiple states of evolving system? That's the challenging part, and these all things are being defined by me in that Heidelberg Laureate Forum and DuxTool seminar, and various of my publication would contain these type of problem definitions related to evolving system challenges. So I worked on this field and domain. So you can have this type of formal abstract view what I have done, and these are just abstract, and detailed research work is somewhere in the other research paper in detail. So like you have various states of evolving system, you have various versions of software. For example, you have various versions of software. You apply some system network evolution mining, then you actually generate some system network evolution information out of this, and you generate the summarized report and time series out of this. Thereafter you have various states of evolving system again, and you have some, for example, some evolving document or some evolving softwares again, and you apply the graph evolution learning, and in this graph evolution learning you generate some of the various kind of neural network, and that neural network would actually do the reconstruction of it and help you do the evolving memory analysis and some recommendation and prediction. So you can do the system evolution analytics out of this. This is just an abstract view of what is system evolution analytics. Then this is evolving systems, like you have various evolving software systems are there. So like for example, I worked on Hadoop distributed file system libraries. There could be evolving nature language systems like Bible translation, multi sports event. So in case of Hadoop distributed file system evolving software system, you have caller and callee procedure, and you can create some procedure call relationship and connections, and that would actually help you do what, call graph analysis. In case of evolving software system, you make what, call graphs, and the network is set to be call graph in case of evolving software system. And when you do the analysis, means system evolution analytics, when you do on the evolving software system, we will say it as evolving evo- that we will say it as software evolution analytics. So in case of evolving software system, we will term this system evolution analytics as software evolution analytics. Then in case of evolving nature language system of like Bible translation, multi-sports event, we could have various words of various documents as our entities, as source entity and target entities in case of directed network or graphs. And in the Bible translation could be some connection, and in the multi-sports event, regional names could be some connections, and they both form some word network. Means there are various words and they form various graphs and network out of them. When we apply this system evolution analytics on evolving nature language system, then we will term it as this application as nature language evolution analytics. So that becomes nature language evolution analytics. Similarly, in case of evolving retail market system, you have frequent market basket, and you have various words related to product and purchasing. So you can have purchasing network, and this type of purchasing network could help you do the market evolution analytics. Then IMDb movie genre system, you can have positive sentiments of movie genre, negative sentiments of movie genre, which would be created with some positive word network and negative word network. These type of sentiment relationship could be there, and this will create some network of positive sentiment network and negative sentiment network. When you do analysis on this type of evolving movie genre system, you will say it as movie evolution analytics. So this is how you can define various evolution analytics for different domains. And this is how you can define various source and target entities or nodes or vertices in a graph. And you can plot this type of graph like call graph, word network, word purchase network, sentiment networks. So this type of relationship could be there. So this type of thing you can do for doing the evolving system analysis or system evolution analytics. So in the next part, we'll see a specific research paper and research work on system network evolution rules. I hope that you had enjoyed this state series part and evolution analytics part. Thanks